Hey, Matt.
Hey, Mike.
Should we continue doing a podcast?
Yes, we have definitely not just continued from where we left off, so we should continue.
You speak the truth, my good sir. Welcome to Hacking the Grepson. I am Mike, and I'm here as always with Matt. Usually, except those few times that I was not.
So not always, but most of the time.
But most of the time. But not all the time. But all the time, except not when it wasn't true. Welcome to Hacking the Grepson, where we will continue in this episode to talk about the 12-factor app. Last time we talked about factors 1 through 5, and we're going to go through 6 through 12 today. But just in case you are tuning in part 2 of a 2-part series, why would you do that? But if you're just one of those kinds of people, the 12-factor app is a methodology for building software as a service, web apps. It's a bunch of guidelines to hopefully make your apps better than they were before you started using the guidelines. You know, use them or don't. So far, we've gone through 5. We think they're pretty good. We're going to go through the other 7. They're probably going to be as good, so you might want to look into it.
Or we might have some super hot takes, so, you know.
Oh, we might.
I don't know if we do, because I don't remember having any as I read it, but we might, so you got to listen to the whole episode, just in case.
I'm just saying,
Look for the controversy.
Factor 6 is processes, and you know that's a hot button issue with software development.
Don't even get me started.
Oh, but I have to. I'm getting you started. Although I think you took 5.
I had the odd numbers, so you have the even numbers.
Okay,
This is
so odd Matt is done for now, and now it's even Mike with number 6, processes. Execute the app as one or more stateless processes or processes. So they say in the simplest case, the code is a standalone script like helloworld.js, and the execution environment is your computer with an installed language runtime like Node.js, and it's launched via the command line by typing node helloworld.js. And then on the other end of this spectrum of processes in apps, we have the sophisticated app that uses many process types instantiated into 0 or more running processes. The point, though, being is that these processes are stateless, much like the web, and they share nothing. So they're kind of their own little fiefdoms that can run on their own, but they do talk to each other, but they don't rely on each other to start up. I think the first thing that comes to my mind when I think about this is running something like Docker Compose up at a command line where you have like the web server, which might be running Node. You have a MySQL database. You might have, an email server or something.
Yeah, and they might all need to know where the other is, but they don't need them to be running. But I think it's the statelessness specifically that's really interesting on this one. Because when you first read this particular factor and you're like, executes the app as one or more stateless processes, if you take the word stateless out of that, it's like, well, yeah, how else am I going to run it if not in a process? So it's the stateless part, I think, that really matters there. So they're talking about not storing data like in memory, but if you need access to it at a later session, store it instead in like a Redis or a Memcached or something like that. There's a talk about not relying on sticky sessions. So, you connected once. Now, the next time you specifically go to connect to my system, you will go to that specific client, or not client, that specific instance of the server or whatever. But ultimately, we don't want that. We want it to maintain that sort of stateless nature so that if something happens and you need to shut it down and start up a new node, no problem.
It's, and they say, like session data, as in you connected before and you wanted to remember who you are, that's a good candidate for your database or memcache, some kind of caching or database thing. Don't put it in the running app session information because, you should be able to just kill it and start up a new one, and it doesn't need to know that you were using it before to function.
Right. If there is stuff that needs to get passed around between sessions and it's not stored, that usually would be sent back to the client application, and propagate it into the next request. If it's usually it's something like a transaction ID or something that might propagate as you go.
Right. Or like a cookie on your browser, that remembers that you were there before. But that's not in the running process. That is a file that was transferred to your browser that you then send back to the server when you reconnect. So I mean, like, what would you say is like the main benefit of doing this? And you kind of mentioned it like it's obvious. So like, why would you ever not do this?
I don't know why you wouldn't do this. No, that's not true. I have definitely written applications that do not adhere to this property, and generally those are long-running applications. They don't get shut down. Mm-hmm. They're dealing with usually a proprietary client you've got basically an open channel of communication, and they're just going back and forth a lot. Often it makes sense to store data there for something that's going to be accessible on the web to a large variety of people, and it's a common server. Dealing with all those, you really shouldn't be doing stateful services. You should be doing stateless. And one of the big benefits of it comes up in a later. Is that the next one? Can I use this as transition? No. It comes up in a later factor where they are talking about scale to some extent. Mm-hmm. And that is a large part of where the stateless stuff comes into play, is at scale. If you have one node of your backend service that your app is using, it could store everything it wanted to in memory as long as you're pretty sure it's never going to get shut down. Cool. You don't even need a database. But the second you spin up a second node, to handle scale or reliability or any of those other, common architectural important factors, if you're storing all your code in memory, well, now you have a real big problem.
I think you have the next odd, number 7. So
how odd. All right, port binding. I didn't have a lot of opinions on this one. Export services via port binding. I think probably reading through the bold points on this page probably gets to the gist of why, which is in my mind more important than the what here. But the 12-factor app is completely self-contained, so you're not. It kind of goes back to the previous bullet, right? It's completely self-contained, so you're not getting extra information from some other magic place. So self-contained, and the web app exports HTTP as a service by binding to a port and listening to requests coming in on that port. So what this would mean is you could theoretically have multiple instances of your service running on the same machine, all listening on different ports. The default standard HTTP port is 80.
Right.
But maybe you have, let's say your only machine is the production machine. I don't know why you're doing that. That's dangerous.
That's your first problem.
Right. But let's say that that's the case. You're running everything from your laptop and you just never close it or shut it down, and it's always on the internet. You have your production environment is probably, it's on that. And if that's on that machine, it's running out of port 80. But when you're doing development, you probably don't want to override the production one. So you would spin up your own on maybe like 8080 or, 4242 or something, like whatever your, however your brain works and you want, or a random port is fairly common as well.
Yeah, I actually have a script on my local machine that just when I have a couple, I have like one for PHP, one for Ruby, and one for Python, and all they are is just little short scripts that create a web server, so that if I'm writing a web app in one of those languages, I can just quickly see it in a browser, and it just grabs the next available port that isn't being used that's above the ports on your computer. I think anything below like 100 or 100 and something are like reserved, or they're the system level ports that in general.
I think it's under 1,000, but yeah.
Oh, under 1,000. Okay. That you shouldn't use. You should try not to use, or you might not even be able to use.
It's in the system space or the administration space. And then everything above that is in the user space, where you as a user on the system it's okay to bind to that port.
Right.
To take it up.
So I like spin up my local web server on 4200, but then if I have another, like the current project I'm working on has both a front end and it has a test app that tests the common library that the front end consumes. And so I like to have those both running at the same time because they have different parts and different tests. So one's on 4200, one's on 4201, but like they could be run on anything. And so that's not part of the app. So that service that they're providing, I guess this is talking about, is I'm exporting it to these ports. You know, it's not like on a specific port that has to exist for this to work. You know, they use 5000 as their option. So yeah, I'm not sure I have a lot to say about this. It's, you're going to export services via port binding. That's how the web generally works.
For the fact-checking portion of our podcast, I will say that system ports, also known as well-known ports, apparently, those include ports 0 to 1023. So we should have realized this was going to be a power of 2 thing.
It's a very power of 2. Yeah, of course.
But didn't think about it. So that's that. And then user ports, also known as registered ports, include ports 1024 to 49,151. Which
49,000.
I assume.
Okay, no.
I assume 49152 is some sort of power of 2 or something. It doesn't sound like it.
Okay, well now I have to fact check your fact check. What did you say?
Quick.
4915.
49151 is the last number, which means that the next one should be an even power of 2.
Now see, this says factors of 49152 are 222222223.
Okay.
It also says 49152 is an untouchable number. I like that. I don't know what that means, but it sounds mysterious.
So 49152 is the beginning of another range of ports, apparently, that goes up to 65,535. And those are called dynamic or random or configurable ports. So now we know more about ports than we used to.
Wow. Yeah, I don't think I've ever tried to use a port that was bigger than 4 digits. So sometimes we learn something on this podcast, so that's awesome.
Yep.
And I will make sure that I forget that as soon as we're done. Okay, so that's port binding. I think we should move on to number 8, which is concurrency.
Concurrency.
I think this is the thing you were thinking about with the scaling.
It goes into it.
I'm definitely going to let you take this one after I just kind of intro it. But yeah, so the number 8 factor is concurrency, otherwise known as scale out via the process model. And, it's basically saying that any computer program is a process, whether it's your web server or your database server or your login server or your email server or whatever. And if you have a small app, you probably only have one process per each of those things to handle the load. But as you get more users and maybe you go viral on Reddit, you might need more. And in the 12-factor app, processes are a first-class citizen. And I think this is essentially saying that you should be able to spin up additional processes as load or scale. If you just want to allow more people in general to use your app, you should be able to scale out the processes, and it should be relatively easy. But I'll hand it back over to Matt for the rest of it.
Yeah, I think
because I don't do a lot of this, honestly.
I think you covered that pretty well.
Okay.
At its most basic, if you want to do any sort of scaling, you're usually spinning up additional instances of your service, right? And there's concepts of vertical scaling and horizontal scaling that we don't necessarily need to get into for these purposes here. But suffice it to say, you have a particular type of service and you want more. You need to be able to do that more because you have more requests coming for that or what have you. You just add more servers with that on it, right? More compute instances, if you want to get more technical, because it might not be a new server. It might be a new container on the same server or whatever. Something else that they talk about in this is breaking up the service into different types, right? So they've got a web process and a worker process and a clock process, and these are all different. They're almost like microservices in a distributed system, except, well, I mean, they pretty much would be.
Yeah, they are.
They are. But they're all kept in the same repo, so it's one app. There we go. I guess. But something I really appreciate that they included here in their picture is the way that they have their scale going. They have 2 web processes, 4 worker processes, and 1 clock process. And I really like that they show that the different processes might need to scale differently based on what they do. You know, you usually will need a fair number of web processes, which are just handling the incoming connections. Because if you have a lot of connections, you know, a lot of concurrent clients, you don't want them to get a connection refused, because that's like the worst case scenario in a web app.
They go away and they don't come back, probably.
Yeah, is they not even being able to connect in the first place. You just it's over. And then the workers, typically you're going to have, you know, those need to scale based on how much they're being used. So if you have a lot of background working processes, but maybe not as many connections, but each connection is doing a lot, you're probably going to have more workers. And then you're probably not going to have a lot of things for, like, the example they use here is clock.
Clock. I don't even know what that's supposed to be.
I assume it's like a system clock or something. I don't know.
Yeah. Well, this kind of like, when I look at this chart, it makes me think of, like, especially in 2024, if you go to some kind of AI generating website where, yeah, you may have a few people on the site asking for things, but they might be asking for 1 versus 20 images to be generated, or they're working on, like, give me this video, you know, a text prompt to video. And so, people keep asking for more and longer things. So we've got to spin up the worker processes, not necessarily the web processes, because it's just these 5 people, but they're asking for a ton of things. And so, yeah.
Yeah. And if you have a super monolithic application, it doesn't make sense to, you know, you can't scale it that way. What that ends up meaning is that you're taking up more compute instance time, which is money, right? You're costing yourself more if you're running. It's basically just an efficiency thing, splitting it up that way. So you're not scaling your clock instance 4 times and taking up whatever memory it is that needs, and maybe all the, like, node modules that had to get installed take up a bunch of space, and, you know, you're keeping the actual runtime more lean.
Yeah.
Which then helps you scale it properly.
Yeah. Another interesting thing is they say the 12-factor app processes should never demonize or write PID files, instead relying on the operating system's process manager. And if you're on a Linux machine, it's usually systemd or something like that. And so when they say demonize, like when you run a process at a terminal, for example, it usually, like, spits out some information, and it might even have, like, a logging or a, you know, some kind of, like, if it's a web server, if I spin up one of those scripts I was talking about that just creates a web server in PHP, if I then go to that website and request a page, I'll see, like, a log message in my terminal saying that I connected, and maybe that it downloaded an HTML file and a JS file and a CSS file. And every time I do that, it writes more things to the screen. But that's taking up my whole terminal as it does it. I can't put any more input. I can only see what that process is doing. But if I run it with an ampersand, at least on a Unix machine, so the name of the thing you're doing space ampersand, then it demonizes it, which means it's still a process, but now it's running in the background, and I can continue to do stuff at that terminal while my process runs in the background. But they're saying the 12-factor app should never do that. Why would they say that, Matt?
That is a good question. It's relying on basically they're saying don't do process management yourself, is I think the way that I'm reading that. And I think that is, honestly, that we can use that as a transition, a segue into the next topic, because I think a large part of that is in using number 9, disposability, right? You want your app nodes to be disposable. They're ephemeral. They're not something that you shouldn't be expecting this thing to be up forever. If you have to, and if you're doing something like process management and whatnot, that app kind of needs to be up forever so that it can manage all the other ones. But if you're relying on the underlying system to do all those kind of things, you're decoupling it from the system, which makes it, just in general, decoupling is good because it keeps things isolated to the parts that they understand, and it makes apps less complicated. But But then in this case, what they're talking about is disposability. They say maximize robustness with fast startup and graceful shutdowns. So the 12-factor apps processes are disposable, meaning they could be started or stopped at a moment's notice. And this is probably the most difficult transition that I have personally witnessed in trying to take a sort of an on-premises web server, or not web server, on-premises backend service, and turning it into a web-based cloud service is specifically in the concept of disposability. It is not a concept that was used much in software development in those, I'm running this on the mainframe and it's going to always be up kind of thing. If you're using the word mainframe, chances are you don't have a disposable app.
You're not. They don't have 12-factor apps.
So having them disposable, what's good about that is it lets you spin up new instances. So that's great for scaling. Going back to the previous one, and then they also talk about shutting down gracefully, and that also gets back into some of what they were talking about with their concurrency model. Because if you were to get interrupted, so your standard run for a service is going to be it comes up, gets some connections or whatever, does some work, and then at some point it shuts down, right? That's the standard one. If it's shutting down through a expected process, like, for maybe a scale event, like, okay, we don't need you as much, what it'll do is it'll shut down the web ports, and then it'll, so it's not accepting new connections, finish off whatever it's doing, and then terminate, so it's not taking up resources anymore. There's a worst case where you have to deal with the actual machine itself dying, and then you have to, that's where you have to worry about robustness, and you're going to run into things like, this one started to accept this request and then shut down. What do we do now? And there's a lot of different ways of handling those kind of scenarios.
So you're saying that this is you're saying that this is a good thing to do, but it's difficult. It's difficult to actually.
It's a difficult transition to make from the older way of writing apps. So this is one of the things I've seen specifically in moving from an older app, like a monolithic app, into a cloud-based, service-based SaaS service.
Yeah. Well, and it seems like if you followed the previous factors in writing your app, once you got to 9, this would be easier. But if you weren't writing your app that way, this one would be a major stumbling block. And
yes,
when I look at this, this definitely, this talks about like the modern app building model. Yeah, this definitely feels like this was written in the age of cloud computing and could not have been written in the age of mainframe or even just like single server. Like when you think about how these kinds of things were written before you could just spin up a cloud instance at a moment to scale or fix a broken process that was, borked in a different one. Normally you just had the one server running all the stuff. And so everything was dependent on everything else. And if one thing went down, it tended to bring everything down. And so obviously we're trying, to go back to number 6, the processes being sort of like the core idea of your app being these processes that run, and disposability is like that you can bring them up and you can shut them down at a moment's notice. You don't start the monolithic like back in Windows 95 time where you're waiting for it to start up and all the stuff is coming up and then you want that to be up for as long as possible. Your Windows computer crashing was like a terrible thing. This is saying if you build your app this way, it's not a terrible thing because you've built it to be process-based, not like server-based, and also that if something crashes, it crashes gracefully, so it doesn't lose data or whatnot, and you can easily bring up another one because it's all in the code base. The code base plus the config is the core of your app, not the place where it's running. That used to be more of the core tenet of what your app was. Yeah.
And I mentioned horizontal and vertical scaling, and I guess it's relevant to talk about here. A little bit on the last one, too. So vertical scaling would typically be you're running something on your machine, and you need to be able to do more, so you have to add more capacity to that machine. Add more RAM, whatever, second NIC card, whatever it is that you need.
NIC card, Matt.
I know. I realized it as it was coming out of my mouth. Horizontal scaling, on the other hand, is spinning up new instances of the service, right? And so this disposability is super necessary for any sort of dynamic scaling in particular, but just in general, if you're doing horizontal scaling, this is where this is a key element of it. This one and that last one of concurrency. If you can't do these, you do not have an app that can horizontally scale.
Agreed. But I'm also thinking that, like, what as important as that is, most of the apps that I've worked on, it would strive to be that good, but we got away with not having that. I mean, like, I think the most that we ever got to was just having, like, load balancing or sharding between different servers so that if one was busy or off, it would just automatically shift to the next one, but not like, oh, we have so much traffic, we need to spin up a fourth shard or a fifth shard, or hey, shard 2 is not doing anything.
Auto scaling is a nice thing to have. Most services do not have that.
Yeah, or don't need it. Yeah.
Yeah. But,
I
if you
think
want
it's
to
an
handle
ideal,
like
but
burst capacity in particular, it's nice to have. It's like you're going to have a spike. If you know you're going to have a spike, you can spin up instances in preparation for that. If you don't, then you have to do it manually, which is, going to be less. You have to do it after the fact, which is more reactive, and you don't want that. But being able to do horizontal scaling at all is those like last three factors all play into that. And then auto scaling is like a nice thing to add on top of that, but not covered, I've noticed, by the 12-factor app.
Yeah, I think it's implied maybe, but yeah. Okay, should we move on to Twitter? I mean X, I mean 10?
Yes.
Okay. So factor 10 is literally the X factor. And it's called dev/prod parity, which means keep development, staging, and production as similar as possible. So this is an interesting one when I first read this, because I wasn't aware that, okay, well, the three gaps that they talk about with dev prod parity are the time gap, the personnel gap, and the tools gap. And historically, these gaps have been substantial and have caused, inefficiency in going from a developer writing code and a production having that code and being used by users. So the time gap is a developer may work on code that takes days, weeks, or even months to go into production. The personnel gap is developers write code and then ops engineers, I would have just said DevOps or ops, but they deploy it. So basically you've got the people writing the code and then they give it to other people who deploy it.
Right. That's sort of the traditional model.
Yeah.
Is that way.
Yeah. But also as like a solo dev, that's not my, because I'm all of it. I'm writing it and I'm deploying it. But yes, if you're at a business, you often would send your code to someone else, at least to like QA it before it went to production, but who knows?
But the people running it, if the people running it in production, like if it requires people to run it, or deploy it, and the people writing the code don't have to be the same people, but it has become that, which is the term DevOps.
Right.
And typically when you're a solo dev, you are doing DevOps.
Right. There wasn't a word for it. Now there's a word for it. And then there's the tools gap, which is developers may be using different tools on their local machine versus the ones that are on the server where it may be running. But whereas the 12-factor app is designed for continuous deployment, we brought that up before, CD, by keeping the gap between development and production small. So they have a nice little table here where the traditional app time between deploys could be weeks, probably longer than that actually, whereas the 12-factor app, hours. Traditional app, code authors versus code deployers, i.e. the devs versus the ops, were different people. In the 12-factor app, they're the same people, i.e. DevOps. And then in the traditional app, dev versus production, they diverged often. And now the 12-factor app is make them as similar as possible. That's kind of, in general, this I mean, this has been my experience, that this is how it goes. But also the interesting one is the dev versus production environment tools. Like in every tutorial I've ever read for any web app development I've ever done, like the tools that I have on my local machine are often, almost sometimes, encouraged to be different than the ones that it's running on. And they use the example of a developer may use a stack like Nginx, SQLite for their database. Nginx is the web server, and then OS X, which is the operating system. Whereas the production might use Apache for the web server, MySQL for the database, and Linux for the OS. Apparently, that should be going away, and I should be doing all of my stuff in Nginx and MySQL and Linux. Although OS X is very similar to Linux in terms of tools and feel, so that's pretty much the same.
Well, so one of the things that they suggest, I don't know if it's here or in another place that I read it, and how I've dealt with this personally in my experience, is to use something like Docker, right?
Yes.
If your development machine is not the same runtime environment as your production machine, running it inside of a Docker container is very beneficial there. For a variety of reasons. One, you're using the actual services that you would be using in prod. So if there is some weird idiosyncratic thing about accessing some service and you don't notice that until you're using that actual service, you would catch it early. And then the main place I've actually seen a benefit to doing this comes down to the libraries. Because sometimes libraries are built different for different operating systems. And sometimes those libraries might work great on, say, OS X, but on Linux in general, not so much, or vice versa. Because they're, those are usually ones where it's not running in the interpreter. It's where it has to actually compile code. And then it starts to violate some of these principles and use like underlying
system tools.
System tools, and that starts to get different behaviors, and then your testing is wrong, and you lose that determinism, which is so important. And even though I don't think they ever use that word in this webpage, is 12factor.net an app? That's a good question.
It's a web app, at least.
Yeah.
Yeah.
I wonder if they use the 12 factors. And I don't think they use the phrase determinism on 12factor.net, but everything that they're talking about ultimately is driving towards that. You want consistent, reliable, deterministic results for what you're doing.
Which, yes, is definitely the takeaway from all of this. But there are so many variables, and those variables change constantly that's why it's often a moving target to try to hit these things. But yes, I don't know why Docker didn't come to mind, but yes, you're absolutely right that Docker is, as far as I know, the best way to handle this because when I was working on Drupal before, or not Drupal, sorry, it was Angular and Symfony, having a like Docker file and a dockerfile.stage and a dockerfile.prod. Like those were the essentially manifests for each server that it would be going to that it would build when you deployed it to those places. But obviously what you should do is you should be building it locally to those manifests to see whether it works before you waste the time using, I think we were using some kind of cloud build and deploy feature to check to see whether everything passed before it, actually put it into production. But yeah, that's what Docker has revolutionized, I think, 10 is being able to have, was it Alpine Linux is like a super small Linux instance, which is often put in these kinds of Docker files. And, actually using like apt-get or yum or whatever the package manager that Linux would use to pull in these tools and seeing whether it actually builds without fail on your local Mac or I guess Windows machine. If only the year of the Linux desktop would finally come upon us, we could stop doing this nonsense because we'd all be running Linux locally anyway. But until that happens, Docker's a nice stopgap, I guess. But but without Docker though, like I hadn't even really been thinking that there was this parity of like, oh, I should really be running my own MySQL instance locally because that's what the production server does on my local computer. With Docker, it's easy. Without Docker, it's harder because you're running all these server instances that you normally wouldn't run when you're just using your local computer. So Docker is a great way to do that kind of stuff. So yeah, dev prod parity. Yes, try to make your environments as similar as possible to avoid that kind of nonsense happening.
I think it's funny that parity and parody sound so much alike and are exactly opposite in meaning in this case. Like, you don't want your dev environment to be a parody of your production environment where it's like similar but making fun of it in some way. You want it to be the same, and you want parity.
Those are the kinds of deep thoughts you come to Hacking the Grepson for, folks.
And then if it could be parrot-y if it talked back to you. This is
all right,
service.
so thank you for joining. Oh, wait, sorry.
All right, moving on. Number 11 is called logs. Treat logs as event streams. Yes, log. It's big, it's heavy, it's wood.
From Blammo.
Yeah. So treat logs as event streams. If I distill this down into one sentence, this factor basically boiled down to just write to standard out.
Yeah. Don't save logs.
Yeah. And effectively what you're doing there is you are then relying on the system running your service to maintain logs, right? So it might use some sort of log rotation, or it might have a way of redirecting standard out to some logging system that lives off, but it's taking it out of the equation for here. A 12-factor app never concerns itself with routing or storage of its output streams.
I am not concerned with this.
Yeah, I've definitely seen this as another. This is probably one of those ones that would be considered a hot take a few years back of doing this. Like, I imagine having arguments with people about this exact topic where they were like, no, I want to maintain control of where my logs go.
I mean, you still are. It's just you're not saving them to endless files on disk.
Right. Well, it's that your app isn't.
Right.
The system might be. Right. You write out standard out. Apache is automatically saving that somewhere. And then your standard log processors can run on that. Right. And so it's really helpful. But I know people that would balk at this pretty substantially.
I mean, so this is not saying necessarily like if you're running a web app and it's on Apache or Nginx, in their config files, they have a log file variable and you say where you want the log files to go. This is not saying to get rid of that. This is saying don't let your app handle it. Let the system handle what happens to these things, because basically logs are just events. Like much like when I was running the local HTTP server and I would request the website and it would say, oh, index.html was requested and CS was requested. Those are events. That is my app doing things, and the system that it's running on should handle what happens to those events, not my app. That's what this is saying, basically.
Yeah. That's how I read it anyway.
Yeah, this seems like another obvious one, but you said people that would balk at this. But why would they, what would they want it to do instead?
I think this just boils down to, again, if you're used to writing software for like a bare metal server that's going to be running on premises, either in your own data center or, at your customers, you've probably written a bunch of code to manage logs. So I think, and I think this goes to the, don't be precious about your code, be willing to throw out your baby kind of mentality is if you're used to doing something a certain way, that starts to become the right way to do it in your mind.
Tradition.
Yeah. I'm not a big fan of tradition for tradition's sake. And if you look at the way that they're suggesting handling this, it makes a lot of sense. And it goes into the other thing that I think is really important that I've also had a lot of disagreements about with people, especially if they come from writing monolithic software, which is I really like the Unix mentality of do one thing and do it well. And that allows you to do this. Then your app is not worrying about log management. It is worrying about writing logs.
Right.
And then something else is dealing with the log management. And you don't have to worry about that inside your app.
Right. I'm in agreement. I'm not sure that everything I've written does this, but in general, this seems like a great idea. So I'm with you. And that brings us to the 12th factor of the 12-factor app.
All right. I expect this one is going to be mind-blowing and like super revolutionary. Let's hear
my
it.
God. Are you ready for factor
am.
12? Admin processes. So this is run admin management tasks as one-off processes. It doesn't actually have a bolded line in the text below, which is just not very consistent of them. I'm trying to remember what one.
So I read this one. I read this one just to like right before we started recording because I was trying to refresh my memory.
Smart idea
on things. This one basically boiled down to you should have anything you need to administer your project, and that would include like ops tools and whatnot, but also things like database migrations and anything else along those lines. Having those be done by script, and ideally having everything about that script within your code base so that you could do like a database migration, like the script that handles that is all built, as opposed to someone going through and manually doing the data migration. I think that's basically saying automate that stuff and put it in your repo. That was my takeaway from this one, and one that I would definitely hope that people are doing. But you know,
I'm looking at this. I'm trying to see like as opposed to like this just seems like you should do this, like you said, as opposed to manually. Like if the database needs to be updated, this is saying your app should have either a script or it should have something baked in, like in Rails it has Rake. Or PHP or console Python, and you know they all have like REPL, the whole read, evaluate, print loop kind of thing that you can jump into in a running app so that you can run things like these scripts or these tools that are built into the language itself, as opposed to changing it manually.
Yeah, this is one of the things I really like about using something like Django or Rails as opposed to rolling my own web development framework, is that it handles a lot of this stuff. Like it comes with scripts to do these things, or at least hooks to call appropriate scripts in certain scenarios, and that is very helpful.
Agreed. And honestly, like I've been doing web development for a while now, that I just kind of expect these things by now. Like this seems like a pretty, to use the same word, codified thing. And so I'm not sure that I've really used a framework or a tool that doesn't have these things. So maybe this is like the most duh thing for me. I'm like, well, of course you run these things. Everything I use has these things. But I guess this was not always the case. Like not every language had an REPL or server admin process things. So yeah, your app should also have these things, I suppose, if you're building one. But yeah. This one was not mind-blowing. I'm sorry. It really went...
I'm sad.
It really ended on a flumph as opposed to a huzzah.
Yeah. Look, guys that wrote this, I am impressed with your Heroku-ness, but like from a performance perspective, you're supposed to start with your second most wowing trick, like right off the bat, or factor in this case, and you can do whatever you want in the interim. But then the last one's supposed to be your best, because then you always leave them wanting more. Like I don't know. Maybe you weren't a big nerd and didn't take magic classes when you were in high school, so you didn't learn that. But now you know.
Maybe this used to be the 11-factor app, and they were just like, 12 sounds better, and they just threw this one at the end to pad it out. Who knows?
Yeah. There's an 11factor.net that someone else wrote, and they just ripped this off and added their own. They're like, admin processes.
Oh my God. Is there an 11factor.net?
Nope.
Nope, there isn't. Okay, well, at least not anymore. Because they...
Or not yet, because I'm sure all of our listeners are going to run out, and somebody's going to register that right away.
Exactly. So so that's all the 12 factors. Just to wrap this up, do you find this a useful manifesto methodology? Like, does this? I mean, you originally said that a lot of it seemed kind of common sense. So maybe the best thing is just that it's, like I said, codified in a nicely written out way. But like, I mean, do you see this like in your life? Like, oh yeah, I've totally seen these things, and people are using it, and it's a good thing.
I would like more of these kinds of things.
Okay.
Where it is like, here's what you should do and here's why. And now if everyone builds things in this way, we understand how they work. It's easy for someone else to drop in and use them or start working on them, etc. So I really like things like this. Sometimes they are really common sense, but what they do is they give people a common vernacular for talking about solutions. And that is that when I was leading the architecture team at my former employer, that ended up being a large part of my job, was just getting everybody speaking the same language about problems. And so something like this is really helpful. If someone says, yeah, we're doing 12-factor development, you know what that means. You know what their app type is. You know what to expect. And so having something like this, I find, is great. It's the same thing as like the Agile Manifesto. It's like, yeah, there's a lot of ways of doing software development, planning and whatnot. But if you're following this thing, anyone else who knows that thing can just jump in and use it. Otherwise, they're learning a new programming language every time, basically.
Yeah, this and just, you know, for your edification, this whole website is in a GitHub repo, and you can download it. And it's actually the official version of this web app. The 12factor.net web app is a fork by Heroku of Adam Wiggins' original. So he went corporate on his own.
Sellout, man, you're sellout.
Yeah, he started a company, and then that company subsumed his personal identity. So yeah, I mean, you can go on here and you can, you know, suggest. There's 59 pull requests waiting. So obviously, some people had something to say about this and lodged, if not complaints, at least modifications.
When was the last approved commit into the main branch?
The last commit was 5 months ago.
Okay, that's not bad.
That's still pretty. That's this year. So
yeah.
It's
better than I thought it would be. Because I don't remember this changing from the first time I read it, and that was a long time ago.
Yeah, I was worried that this would, have not been touched for... Well, but that's the thing, is you could also look at it as like, if it hasn't been touched in a while, that just means that it's done. Like, we're good. You know, until like major technological changes happen and AI writes all software, there's no updates that need to be done. So, anyway...
Cool.
Well, thank you for everybody joining us on this two-parter about the 12-factor app. Seems like a pretty solid foundation to build your app on. And we give it the Hacking the Grepson seal of approval that I just made up.
Yes. I was trying to come up with a verbal seal, and all I could think of was or.
There you have it. It gets the official of Hacking the Grepson. And if you want to listen to more episodes that we've given our seal of approval to, because we uploaded them to the internet, you can go to hackingthegrepson.com. Until the next time we talk at you, we now return you to your regular... Oh, right. We try to put episodes out every other week on Wednesday. So I had to get in there. Until then, we now return you to your regular scheduled lives already in progress.